Ah, yes, tin men, tin foil, tin cans, all wonderful items made entirely out of tin. They're not, really, but they used to be. Cans are now mostly made out of steel, with a coating of tin, also known as tin plate. Steel has made the cans more durable and cheaper to make, but the cans still make use of the corrosion resistance of tin. Tin foil has been replaced with aluminium, as wrapped food tended to get a slight tin taste. And not only is aluminium more flexible, it's cheaper and also more durable than tin. Despite all that, tin is still used for many different purposes. Its anti-corrosion properties make it the most preferable choice for coating food cans. Unlike other metals, it does not react with the acids produced by food. Its low melting point and general malleability makes it optimal for soldering. While tin metal, its oxides and salts are almost unknown in toxicity, its organometallic compounds are almost as toxic as cyanide, as it interferes with iron and copper metabolism. This makes the difference between tin's use as a coating or as bactericides and fungicides. Most of the tin mined today is coming from Indonesia and China. Tin is mined on the land, largely by hand. Men scrape the ore out of the ground with pickaxes and buckets. In the Indonesian Bangka Belitung Islands, where 90% of Indonesia's tin is produced, this process has formed large holes, and the risk of cave-ins increases with the ever-widening and deepening of these holes. These cave-ins, among other causes, were responsible for the death of one miner a week, reported back in 2011. If that is not dangerous enough yet, attacks by saltwater crocodiles are getting more frequent near the shores. And what the miners earn for this? They get their equipment and the equivalent of a whole $5 for a successful day of mining. The land is not the only source of tin, though. The sea contains a lot too, but the consequence of mining at the shores is problematic. The water becomes clouded, followed by the withdrawal of fish and shrimp and the burying of coral reefs. Instead of fishing at 5 kilometers from the shore, they now must go to a distance of 13 kilometers for small fish and shrimp, and even 27 kilometers for larger fish. This happens even though there is a prohibition on mining in waters within 7 kilometers of the shore. In the EU, tin is not yet considered a critical element, but in China and in the US it is. This is because there is a low supply risk for tin in the EU. It is calculated, based on the tin mine production in 2019, that we still have tin reserves that will last at least 50 years. But 56% of the tin mined in 2019 came from CRIRSCO complaint resources. The CRIRSCO is the Committee for Mineral Reserves International Reporting Standards. There seems to be quite the lack of push toward the replacement of tin, though advancements have been in progress for years already, such as the thinning of tin plating, replacement with aluminium, etc. For example, in solder, it is the lead component that people seem more concerned with, and every alternative alloy still includes tin. In the food industry, it's very important to be careful with implementing new materials too fast. Take the discussion around the influence of softeners in plastic containers on fertility, for example. Of course, these examples have to do with the specific properties of tin as a material, making it not yet easily replaceable. But if the biggest contributions to globally consumed tin are still made through unethical sourcing, like those heavily underpaid workers having to put their lives at stake to source tin, a stronger push for developing alternative materials could be warranted. Sources expressing worry over the metal potentially declining in competitiveness on the market come off tone deaf when laid side by side with sources describing working conditions in the tin mines of Indonesia. Recycling will play an important role in the future tin supply, but there has been limited investment into technology to recycle tin, so it will take some years before the major tin resource can be extracted efficiently out of used materials. The demand for recycled tin will eventually grow as the demand for tin rises. This demand will grow because tin is used in superconductors, which are not used much today, but come with a lot of promising future applications such as power storing devices, electric motors, maglev trains, and a lot of other applications we might look to use in our quest for CO2 neutrality. Whether or not tin is to be considered a critical element seems to be largely dependent on market developments, the geopolitical climate, and the exhaustion of both known and new resources. But if it keeps towing the line as it's currently doing, a little caution toward long-term use is warranted.